Hey guys, in this video I'm going to be talking about absolute value equations, and that's exactly what it sounds like. They're going to be solving equations that have absolute values in them. All right. Now before we jump into the equations themselves, it's probably a good idea to go back and remind ourselves what an absolute value is and kind of work with those a little bit. So let's do that first. I'm just going to write down an absolute value, and most people when they see this would say, oh, I know what that is. You take that and you make it positive, right? And you wouldn't be wrong. And if I gave you something, let's say like, uh, a positive number, um, remember you don't change the sign. What you're doing is you're making it positive once again. Now, without any context, you might look at this and say, well, from the pattern I see, it looks like that whatever sign I put into that thing, all it's going to do is just pop out a positive number. Therefore, absolute value means to make something positive. Uh, While practically that is what you're doing, you are just making negative numbers positive and leaving positive numbers positive. That's not actually what it is, if that makes sense. That's what you do practically, but that's not what it means. And to explain what I mean, I'm going to draw a picture for you. All right, so I'm going to draw a number line. You may have seen this before already, I don't know, but it's good to go back over these things just to make sure everybody's clear on it. All right, if I were to pick any number, I'm going to use a different color here. Let's use this. Let's say I pick the number, well, let's pick 2 because I already used it. I pick the number 2, and I want to know answer the question, how far away from 0 is 2? Well, I look, and it's 1 unit, 2 units, okay? And that makes sense. It's 2. You start from 0, you go to 2, you've gone 2 units, right? But what if I start at -2? And I ask, same question, what is the distance? I don't care what direction I'm going. I'm asking, what is the distance that I have to go to get back to the origin? Well, that's 1 and then 2. I'm still going 2 units. All right. And that's actually the definition of what the absolute value is. The absolute value is the distance a number is from the origin. Now, with what we're doing right now, it's just going to be a number line. The reason we want to think of it this way is later on, when numbers become two-dimensional, and you can even make three-dimensional numbers, you're going to be talking about the distance between that number and, say, the origin, 0, 0, or something like that. Now, I'm not going to get into all that stuff, but that's why we need to want to think about absolute values as being a distance as opposed to just make it positive, because it's not always going to be the case as we get into other things like complex numbers and such. But that's not important right now, but I wanted you to see it. All right, so let's talk about what an absolute value equation looks like. Let's just do one. I'm going to give you a very, very simple one. Okay? Now, what this is saying is I've got this thing right here. Now follow me here. I've got this thing, and when I take the absolute value of this thing, whatever it is, right now it's x plus 2, the answer should be 6. All right? Now, as we go through these videos, just a quick note, I highly encourage you to pause these videos and try these things on your own. Even if you've never seen the technique before, or you don't even know how to do it, just give it a shot, think about it for a minute, and then come back to it. Because I found that when students wrestle with a problem, even if they don't know how to do it, just try some things, wrestle with it, and then when you see how to do it, it makes it more effective when you actually learn the technique, and you'll remember it better. Okay, so pause this for a second. Try and figure out what x has to be. In other words, what number would I have to put here so that this thing is actually true? And when you've wrestled with that for a bit, and you may come up with an answer or two, come back and I'll show you how it works. Okay, so let's think about this in this way. Now, when I was shown this, my teacher, from what I can remember, because it was a long time ago, just showed me what to do. And they said, well, you'll see in a second. But they never showed me why I had to do what I did. And it always bugged me. So what I'd like to do is talk about why I'm going to do it first. So this thing right here, if I were to delete it, you know this is x plus 2. So you remember that. I want you to don't forget that. I'm going to delete it right now. Something has to go here. We know it's x plus 2, but don't worry about that right now. What number would have to go right here to make this true? Well, you could put what? You could put a 6 in there, couldn't you? Because the absolute value is equal to 6. What else could you put in there? Well, you could put a negative 6 in there. And if I put a negative 6 in there, the absolute value of negative 6 is positive 6. So the options are, let me erase this. So the options for the stuff in here are 6 and negative 6. Okay? So let's go back to what's actually there. So this is what is actually here. What did I say, x plus 2? Right. So x plus 2, for this thing to be true, this, now it doesn't matter what it looks like. This could have x's and y's, and it could have all kinds of stuff and variables everywhere. But whatever is in here, it still has to be either the same as this or the same as this. Well, how do we say something is the same as something else? Well, in math, we say they are equal. So what I'm going to do is I'm going to say x plus 2, this thing, has to be either a 6 or this thing has to be a negative 6. All right? Now, when I first saw that, I thought, okay, you took the absolute values bars off and you put a minus sign on the right on one of them. Now, yes, that is what I did. And if that's all you get out of that, then you will be able to do these problems and you will get them correct. But I do want you to think about the reason why that's happening. We're not just taking this number and going there and there and putting a negative. Yes, that is what you're doing, but that's not what's really happening behind the scenes, is it? So what we're really saying is this thing right here has to be a negative 6 for it to turn into that number. Or it has to be a positive 6 for it to become this, in kind of a logical way. I hope that makes sense. Now, if you don't like thinking about it that way and you don't like the logic, that's totally okay. Would I like you to understand why I'm doing what I'm doing? Sure. But at the end of the day, if you take the absolute value bars off and you just write 6 and negative 6, you'll get the answer right. So practically, there is no difference in the result. Okay? All right, enough of me talking about the theory of what you should and shouldn't know. Let's just do this thing. So these are just basic equations. I'm just going to subtract 2 over here, and I get x equals 4, right? And over here, I get, well, subtract 2 from both sides. This is negative 6 minus 2. I'm taking a negative 6 and I'm making it more negative by 2, which means it's going to be what? Negative 8. All right? All right, I'd like to try to, I'm going to plug this in and verify for you that this does work. So if I put a 4 here, let's try it. So if I put a 4 here, 4 plus 2 gives me 6, and then absolute value of 6 is 6. Okay, that's easy. What if I put the negative 8 here? Well, a negative 8 plus 2 is what? Negative 6. And the absolute value of negative 6 is, in fact, 6. So keep in mind that whatever the answers are that you're getting, you're looking for things that make this statement true. So you can always check to find out if they're true or not by just plugging them in. Just stick them there and see if it works. It's also another strategy for solving them in the first place. You can kind of guess and check if you'd like to use that method. But this one here that I just showed you, where making the two equations, that will always work. All right. Let's talk a little bit about, well, you know what? Let's not do that. Let's let you do one on your own before I start getting deeper into this. So I'm going to write another one up here. I'm going to keep it very simple, again, and I want you to solve this. All right. So pause the video, give it a shot, and then come back and we'll do it together. All right, I assume that you have tried this. So remember, this thing, whatever's in here, has to be equal to the negative version or the positive version of that. So I'm going to write x minus 3 equals 10, and x minus 3 equals negative 10. All right, now I'm not changing this 10 to a negative, remember? I'm just saying this thing in here has to be negative 10. Okay, so now I'm just going to work it on the left. Let me use my color again here. Plus 3, x equals 13. On this side, if I add 3 to both sides, I get x equals, that's a negative 10 plus 3. I am decreasing the negativity of this negative 10. I'm taking a negative 10 and adding 3 to it, so it's making it less negative, isn't it? So that's negative 7. All right. That's how it works. It's really not more complicated than that. Now, we are going to add some more things to it and make this a little bit more involved in a minute. But not yet. Let's do one more, and then I'm going to show you kind of an interesting way to think about why this works. Let's do one more. Let you do it. Let's come up with one that's pretty small, so it'll be easy to do. All right, pause it, try it, then come back. All right, now, if you don't like thinking about this stuff, like I said before, the upshot to this topic is you really can just write this down and then write it down with a negative sign and not really think about it. I'd like for you to think about it, but again, if you just do this, you'll get the right answer. And subtract 2 from both sides, I get 3. Over here, if I subtract 2 from both sides, it's negative 5 minus 2. It's a negative 7. All right. Now, I showed you what it means when you plug these things in. So let's say if I plug in a 3, 3 plus 2 is 5. Absolute value of 5 is 5. If I put a negative 7 here, negative 7 plus 2 is negative 5. When you take the absolute value, it's 5. So it does work if you plug it back in and want to check your work. What about visually? I'd like to show you real quick what that looks like on the number line. What does this mean? Because, we talked about how the absolute value really means a distance, right, from 0. So what I'd like to do is show you what that means and what does it mean to have an equation like this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So what does this mean? Well, it means that I'm looking for numbers that when I add 2 to them, they are the distance of 5 from 0. Okay, I'm going to say that again. So I'm looking for numbers that whenever I do stuff to them, it might be plus 2 in this case, it might be times 7 minus 13, it might be whatever this mess is. It doesn't matter what that mess is. I'm doing something to x, and after I do that thing to x, it is some distance. What distance? It is 5 away. It is that distance. So let me show you what that looks like. We are claiming that 3 works. Okay, so where's 3? If I plug in 3 here, there's 3. Let me use a different color, make it a little easier. So here's 3, right? And this says when I plug in 3 and then I add 2 to it, so that's here, this number right here should be 5 away from the origin. Is it? Well, yeah, it is. That's actually the number 5, isn't it? So that works. What about the other one? Let's do the other one. Let me get rid of this so it's not all over the place. Well, negative 7, let's check. So I made this in such a way that this was negative 7 down here, right? If I counted correctly, 1, 2, 3, 4, 5, 6. Yes, that's right. So I'm looking for the number that's such that if I add 2 to it, remember adding means going to the right, always, on a number line. So if I add 2 to it, I arrive where? Well, I arrive at the number negative 5. Is negative 5 the distance 5 from the origin? Yes, it is. This number that I've arrived at by adding 2 will be that. So it's kind of neat to see, these aren't just letters and X's and numbers and bars and stuff. Like they mean something. When I stick a number here and I do this thing to it, it becomes this distance from the origin. Now I won't always do that with more complicated examples, but I did want you to see what that means. All right, let's make these a little bit more interesting. Let's add some more things to it. Before I make it too crazy, I'm going to give you an example. You try this one. This one's not hard. You should be able to do this one. Let's see. Let's go with 9. All right. As always, pause it give it a shot, come back, and I will do it with you. All right. This is really, again, not difficult. There's nothing really challenging here. I added a coefficient here, meaning the number in front of x. But the way you work this out is exactly the same. All right, so I just make that 9 a negative there. And I solve it. I move the 1 over, and I get 2x equals 8. Divide both sides by 2, and I get 4. Right? Over here, I subtract 1 from both sides. This is negative 9 minus 1 is negative 10. I divide both sides by 2, and I get negative 5. All right? So if you have like a two-step equation here, not just a one, but a two-step, it works exactly the same, right? You just set it up the same way, and you do that way. All right? All right. Now, this is where it gets a little bit more interesting. How about something like this? Oh, I don't know. Let's go with that. All right. Now, before you watch me do this, it would be in your best interest to try this on your own, right? Give this a shot first, even though you may not know how to do it, and then come back and we will work through it together. Okay. Now, my guess is many of you may have decided that these basically look like parentheses, right? And when you see parentheses and you want to solve something, you distribute, right? And then work it that way. While that will work sometimes, it does not always work, okay, in this context. So I would like, so it's my, well, when I do this, it's probably best to just, or it's my view that it's best to not, don't even entertain the idea because you're not technically supposed to do that. It will work sometimes, but it's not supposed to, if that makes sense. All right, so what I'm going to do instead of distributing, let's pretend this thing right here was just an x. If this was just 2x equals 14, right? If it was just an x by itself, what would you do? Well, that's easy. You would divide by 2 to get rid of the 2, right? Well, it's the same thing here. Just pretend, let me get rid of this. Pretend that this thing right here is something, it's just a variable, right? Just leave it alone. You can't touch it yet. The goal, remember, the goal of solving an equation is to get rid of the other stuff. I want to get rid of this too. Well, it's being multiplied by something, right? So to get rid of it, all I have to do first is just divide by 2. If you do that first, it eliminates the problem. So now, if I divide both sides by 2 first, then I just have a simple problem like this, right? And now I can work it just like I've worked the other ones. X equals, well, let me see, x plus 4 equals negative 7, x equals 3, and x equals, was it negative 11? Uh-oh. I don't know where that came from. Okay. So, when you see something like this where you have a number out front, go ahead and eliminate it by dividing both sides by that number. All right? Okay. Let me give you another one. You try this one on your own. See if you can do it. Let's see. What do I want to make this number? How about that? That should work, right? Okay. Give that a shot and then come back and we'll do it together. All right. This is actually going to introduce two things to you. One, it's going to give you practice doing what we just did, but you may find that if you tried this already, you probably ran into a small problem, right? And let's kind of go through it. So again, I want to get rid of this 2 first. I'm not going to do the distributive thing. We're just going to get rid of it. Divide by 2, divide by 2. So I have absolute value 3x minus 1 equals what? 11. And now I'm just chugging along the way I usually do. I write that down. I write this down. Right. Now, on the left side, if I add 1 to both sides, I get 3x equals 12. All right. And that's going to give me x equals 4. All right. So far, so good. No big deal. Now, on the right side, if I add 1 to this side and add 1 to this side, well, I'll get 3x equals, that's negative 10. And some of you guys may have gotten stuck here, but remember, this is Algebra 2. We're not supposed to be worried about things like decimals and things like that, right? Don't let this scare you. You can just do this. So if I do that, it's going to be x is equal to, well, that's going to be what? Negative 3 1/3, right? Or negative 3.3 repeating. So you can get decimals for these answers. All right. So don't be afraid of that. Just have a calculator handy, and or if you're able to do them in your head, you can do that too. Just either way. Just know that this is a possibility. All right. Okay, let's take this another step further. All right. And I believe this next step further is going to be the last one we're going to do in this video, at least. Let's say this one. Let's go with this. Okay. Pause this, try this on your own, and then come back and we'll do it together. All right. Now, here's why I said not to do the distributive property. Most of the time, this will work when you don't have other stuff going on. But if you try to do the distributive property and treat this like a normal equation, it won't work. It's not going to give you the right number. So, like I said, don't worry about it. Don't do it. The other thing you need to recognize is that if you do the method that I just showed you, where you divide both sides by this number here, you can't do that yet, can you? Let me show you why. This may look really complicated, but I want to draw your attention to the fact that this is just a thing times 2. So let me do something kind of weird. If I drew 2 smiley face minus 6 equals 12. Okay, I've just replaced this stuff, with a smiley face. It could be an X, could be Y. It doesn't matter what it is. The point is, it's just 2 times something, right? If you saw this isn't confusing. Well, maybe it is, because you've probably never seen a smiley face in an equation before. But my point is, I don't want you to think about anything in the smiley face. There's nothing in here. Nothing in here matters right now until you get rid of everything else. So if this were the case, what would you do? Well, you'd add 6 to both sides, right? You'd eliminate that. Then you would divide both sides by 2 in that order. That's how you do two-step equations. Well, that's the way I want you to think about this. All right, so this, get rid of that stuff. It's the same thing. Before you touch this thing, oh, that was weird. Before you touch this thing, and before you mess with that too, you have to get rid of the 6. So let's add 6 to both sides. That's gone. I have 2. X plus 4 equals, this is 18. All right. Now again, let's get rid of that thing in front. Slide that up. So I have divide by 2, gone. X plus 4 equals 9. And now, again, this is just a very basic example, just like we did at the beginning. You just write it down twice. This one's a negative, okay? Actually, did we do this exact one earlier? Maybe. Looks familiar. Okay, so I subtract. I don't use a script or anything. I don't write down examples. I make these up off the top of my head, so it just looks familiar. I don't know if I did this before or not. So if I subtract 4 both sides, I get, what is that, negative 13? Okay. So that's how you would handle something like that. And the reason we want to do things that look like this is later on when we start graphing these equations, you will see absolute value equations that will look like this. They'll have a number out front, a number inside like this, and a number on the outside like that. And so it might be beneficial when we get to that unit to know how to solve them in this way. Okay? Great. Let's do one more, and then we're going to call it a day. one more to see what you can do with it. All right, let's put everything together. Let's use something besides 2. Let's do 4. Let's do 2. All right, let's do 25 should work. All right, give this one a shot. And if you can do this, then you have mastered the art of the absolute value equation, or at least at this level. All right, give this a shot, and then you can come back and check the answer. All right, I'm assuming you've gotten this right. So what are we going to do first? Let me use some different colors. I hadn't done that in a while. I've got this technology. I might as well use it, right? So I add 3 to both sides, and I get now, well, this is still here. That's gone. 20, 28, right. Now, I want to get rid of the 4, so let's do divide by 4 on both sides. That's gone. So now what's left? 2x plus 1 equals 28 divided by 4 is 7. And now, I'm going to, at this point, and only at this point, am I going to break this apart. Let's use green. 2x plus 1 equals 7, and 2x plus 1 equals negative 7. All right, so those are my 2 equations. Now I'm going to go down here and solve them. If I subtract 1 from both sides, I get 6. Divide that by 2, I get 3, right? All right, over here, let me go a little slower. If I subtract 1, I get 2x equals, that's negative 7 minus 1 is negative 8. And divide both sides by 2, I get a negative 4. All right? So, if you can do that, then you're doing great. All right? And that is how we solve absolute value equations. All right, I appreciate you guys' attention, and hopefully this was instructive, and I'll see you guys in the next video.